ለመማር ወደ ትምህርት ተቋም መሄድ ግድ አይደለም። ናሽናል አቪዬሽን ኮሌጅ
ራሳችሁን ከኮሮና ቫይረስ ወረርሽኝ እየጠበቃችሁ በቤታችሁ ወይም በተመቻችሁ ቦታ በኢንተርኔት አማካኝነት በኦንላይን ትምህርታችሁን መከታተል ትችላላችሁ።
ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ኢንስቲትዩት ኦፍ ኮመርሻል ማኔጅመንት ICM ጋር በመተባበር የሚሰጡ ትምህርቶችን ተከታትላችሁ በ6 ወር ጊዜ በዓለም አቀፍ ደረጃ ተቀባይነት ያለውን የስልጠና ማስረጃ ባለቤት መሆን ይቻላል።
ልምድ ባላቸው መምህራን እየተማራችሁ ጥያቄና መልስ፣ የክፍል ስራዎች፣ ፈተና መፈተን ክፍል ውስጥ እንዳላችሁት አይነት በኦንላይን ባላችሁበት ቦታ ከናሽናል አቪዬሽን ኮሌጅ
የናሽናል ኤርዌይስ እህት ኩባንያ
But anyway, we looked at an illustration yesterday that gave us on how to go about this. And the same procedure is the one you're going to use to determine the risk of a portfolio as well as the return of a portfolio. There are steps that we discussed before coming up to this point, that for you to determine the risk of a portfolio or the return of a portfolio, you must identify the proportion. That's one of the issues that you have to know. And in this case, we are told the proportion is 50-50, all right? In our illustration, I don't know whether you saw this, but let me just show this because it's being asked. The finance manager of Addis Limited is considering investing in 2 risky projects. He is in a dilemma as whether to invest in each individual or in both jointly at 50-50 or in 50-50, that is 50% proportion. He has provided you with the following information, and then you are supposed to advise him accordingly. So once you get these are state of economy, they are bad, very bad, bad, average, good, very good. And then there's the cash flow probabilities, and the total of this should give you 1, cannot go beyond 1, or it's not supposed to go beyond 1. Then these are the returns for project A, and these are returns for project B, okay? So these figures are the ones I've just copied, and I've shared them here. These are the ones. The probabilities are here. The return for A is here. 14%, 17%, 20%, 24%, 26%. Return for B is 12%, 11%, 10%, 8%, 10%. Now, we are supposed to determine the return. If you recall what we did yesterday, we are getting the expected return from project. Then we use the 14, like the figure that we had anticipated to get, minus the expected with the bar. You know, this bar means a lot. It means this is the computed one, and this is the expected. So the computed one, this expected minus the computed one will give you a variance, all right? So this is what we are looking at. But before we come to this point, because this will help us determine the covariance and the correlation coefficient of the 2 assets or the 2 investment projects. So we need to start with the determination of the return for each of the individual projects in the portfolio. So we need to know the returns of each individual project in the portfolio and the risk of each individual project in the portfolio, just like we did yesterday, if you recall. All right. So what is the return for project A? Who can give me the return for project A? How do you determine that? How do you determine the return for project A?
Probability times.
Yes.
Times project A. Return plus Yes. 0.3 times 20
Yes.
plus 0.3
0.3.
0.3 no 0.1 24 plus 0.1 times 26.
So this would give us what?
Return A.
Yes. What is the answer? What's the answer? If you work out with that, what's the answer?
Wait for a minute.
Okay. I told you guys to come with the calculators. Huh?
Yes.
This is like a mathematical class, so you need to do a lot of calculations. Huh?
18.9.
18.9. No?
Yes.
That's what you're getting?
Yes, I
Who
think.
else is getting a different answer? Who else has a different answer? Okay, can you determine for B?
Okay, we can similarly.
You have the same format.
Yes, 0.2 times 12 plus 0.3 times 11 plus 0.3 times 10 plus 0.1 times 8 plus
All right. So can you give me for B as well?
Okay. Yes, times
For B as well.
I think 10.5%.
10 point?
5%.
10.5%.
Yeah.
So can the rest confirm that? Is that correct?
Would that say? Would
Are you
that say?
getting the same? These people are not
Would that
coming
say?
up, huh?
Would that say?
Yes, I'm trying. Yes.
Okay.
What are you getting for A?
Tamiru.
Huh?
Are you getting different answer?
Are you getting different answer? Okay.
No one.
How
No,
much?
no, no. Same.
Huh?
10.5. It's 10.5.
For A.
For B.
For B.
For B.
Yeah.
All right. Good. So now what is next? We need to determine the risk of each of these assets, so that once we get the risk, first of all, we can determine the portfolio return. The return of the portfolio is equals to 0.5, all right, times 18.9. If you recall our formula, plus 10.5. Sorry, let me start with the proportions first. 0.5 times 10.5. So what does this one give us? To get the return of a portfolio, work out this and give me the answer. What do you get?
It's 14.7.
14 point?
0.7.
0.7.
7.
Like that.
Yeah.
14.7. 14.7. That's 14.
Okay. That's the return on
14.7.
1.4.
14.7.
All right. Can you read this, what I've written?
Yes.
Can you read this? Is it the correct
Yes,
one?
yes, you're right. Yes, yes.
All right. So now we want to go into determination of risk. We've been able to determine the return of each individual portfolio, investment in the portfolio. And then now we've been able to determine the return of the whole portfolio. So we want also to determine the risks of each individual investment, as well as now the risk of the each and every portfolio. So for us to determine the covariance, because for us to determine the risk of a portfolio, we have to determine the covariance between the two projects. And for us to determine the covariance between the two projects, we must determine the risk of each and every project that we are putting in our portfolio. So that's why I put this, so that it can be easier for us to work it out, so that whatever total we get will now represent the variance or the covariance we are looking for. So what is our RA minus RB for case 1? RA minus bar RA. That is means 14 minus 18.9. What do you get? 14 minus 18.9. What do you get?
4.9. 4.9.
Negative or positive?
Negative 4.9. Negative.
And for this one, 17 minus 18.9, what do you get? Should be negative as well.
Mm-hmm.
Negative what?
Mm-hmm. 17 minus 18.9. Negative 1.9.
Yes. Negative 1.9. 20 minus 18.9, that's a positive.
Hmm.
20 minus
minus
yes,
80.9, 2.1, positive 2.1, positive 2.1. No, 1.1.
Huh?
1.1.
1.1.
Positive 1.1 is.
Okay. 24 minus 18.9.
24 minus 18.1. 5.1.
5. 5.1.
7.1.
Huh?
7.1.
7.1. Here.
Yeah, yes.
7.1. Okay, same for B. Can you work out for B and give me the figures? 12 minus 10.5. All right, like that.
Positive 1.5.
1.5. Then 11 minus
0.5. 0.5.
And then
Negative
the next one,
0.5.
negative
Negative
0.5.
0.5.
Then the other one, the next one,
Negative 2.5.
negative 2.5.
Mm-hmm.
The other one, where are we? This
Negative
is
0.5.
negative.
0.5.
Wait a minute. This is for that. This for that. This for that. This for that. So we are on the last one. Negative.
Negative 0.5. 0.5.
0.5.
Mm.
That is 7.1. Sorry. 10 minus 10.5. Good. So our next step would be now RA minus RA by RA, okay, square times PI. So just take this, you square and multiply by your PI. PI is the probability. What do you get for A?
For A.
Yes. So you square the negative 14.9, then multiply by 0.2. So you do like that. What you get for A? What do you get for scenario 1? What do you get here? You square this and then multiply by 0.2. What do you get for scenario 1?
Scenario 1. 24.2.
Yes. We already have the figures. is negative 4.9. You square that, and then you multiply, because a negative plus a negative times a negative, once a negative, when you square negative, you get a positive. You multiply by 0.2.
Is that 1.6?
Hmm?
1.96. 1.96.
You recall what we did yesterday? We are taking this minus this, all right? And when you take 14 minus this, you get that, all right? So this figure, you square and then multiply by the probability. So that's what I'm asking for. And we already have negative 4.9, all right? We need to square that. Get negative 24.01 times 0.2. We get negative
4.8.
4.8%.
Are you getting that one?
4.8.
0.2.
Yes, it's 4.
Okay. Then we take again negative 1. A negative, a square of a negative is what? It's a positive, isn't it?
Yes.
Yes. So this one should be positive 24.01. Right?
Yes.
So can you also do the square root? Sorry. This, then you multiply by 24.01 times
0.2.
0.2. Yes, yes. So you get 4.0.
4.8.
4.802. Are we together?
Yes.
Yes, that's the correct answer for this case 1. Can you do for case 2? And give me the correct answer. Do for case 2 and give me the correct answer.
3.888.
3.888. Okay. For case 3?
0.363.
0.363. 0.363. Next one.
2.601. 2.601. 601.
01. Okay. Then the last one.
Last one. 5.004.
5.004. 5.004.
04. Yeah.
004.
No, 5.041.
Okay. Zero, 4, 1, like
1.
that.
I think.
Okay.
Is there any complaint?
Total of that? Now,
of
yes.
that,
Can we hear
66.
from any other the others who have a different answer?
No. Okay. Total of this 16.656. 16.
Now, how did you get the second one? I was just confirming the second one. It is
1.9.
negative.
Yeah, negative. 1.9 square. 9 square. Square 3.6.
Wait a minute. Negative 1.9. You square that.
Square. 3.6. It will be 3.61.
3.61.
Okay. That okay.
Times
1. Okay. Times 0.3.
Times 0.3. It will give you 1.083.
That.
What are you getting?
I don't know. 3 points.
1.083, not 3.888.
3.6 times 0.3. 1.8. You're right.
Yeah. So are the rest with us? Why am I getting the wrong answers and yet you are just following? It's 1.083. 1.083. Okay. The next one, you want us to confirm again. It's like all your numbers are not correct. Can you, Girma, can you confirm that?
Okay. The next 1.1.
What is the answer for the next one?
1.1.
1.1.
1.1 square.
1.2.
0.363.
0.363. How?
Square of 1.1.
What?
1.2.
1.2. This is 1.2.
Why?
This is what you gave me.
Okay. No.
20 minus 18.9.
1.1.
I mean, 20 minus 18.9.
20 minus
1.1. You gave me 1.2.
Yes. No, 1.1.
Yeah. That's why the problem is.
1.2. 1.1 square times 0.3.
And is this one correct? It means like I have to confirm all these figures.
Okay.
17 minus 18.9. 1.9, yes, the other one is correct. And then 24 minus 18.9. 5.1, yes. Yeah, these things are so simple. I don't know why you are missing out on simple calculations like this. 7.1, yes. Yeah. So as I write, I hope you're also seeing what I'm writing so that if in case there are any errors, you correct me. So once you get, if it's 1.1, then you square that. You get 1.21, times 0.3. You get 0. Yeah, so this one is correct. The next one is also a positive. Positive, you get that one, yes. Yes, so negatives are the ones that are difficult to work with, but now you've seen how to go about them, isn't it? Am I right?
Yes.
So what is the total of this? This will be our variance for A. Total of this? What is the total of that? When you add all those figures?
I think 13.
Huh?
13 point.
13
Point.
point
887.
887.
7.
So for A, our standard deviation for A is equals to square root of 13.887, which gives us what? Okay. Then we also have RB minus by RB u square multiply by PI. So you do the same for B to determine your risk for B. So what is the standard deviation of that?
3.726.
3.726.
726.
5. Okay, standard deviation of B. Now I want you to do the same for B and give me the total, then we apply here. All right, just using the same formula. Emebet, are you following what you're doing?
Yes, doctor. I'm
Yes,
following.
can you work out for B so that you give us the answer? You know, this is about
Sorry,
practicing.
doctor, I don't have calculator today. That's why. I'm sorry.
And I said it yesterday that you should come with calculators.
Yes, yes.
You don't have your phone? You need to have a scientific calculator. Scientific calculator, the one that you can just click on the square, it brings you the answer. The square root, you just click on the square root and type the figure, it gives you the answer. You know, understanding how to use the calculator is another problem for students. This is what we've noticed. So it's good you practice this when in class than waiting until you go to the exam and then you're going with a calculator which you don't know how to utilize. So can you work out this so that you give me the answer? 4.8.
በትምህርት ከፍ ብሎ መብረር ይቻላል። ናሽናል አቪዬሽን ኮሌጅ የናሽናል ኤርዌይስ እህት ኩባንያ ከከፍተኛ ትምህርት አግባብነትና ጥራት ኤጀንሲ ሙሉ ዕውቅናን ባገኘንባቸው በማስተርስ ዲግሪ ኤምቢኤ በስትራቴጂክ ማኔጅመንት፣ ኤምቢኤ በባንኪንግ እና ፋይናንስ፣ ኤምቢኤ በቢዝነስ ሊደርሺፕ፣ ኤምቢኤ በሪስክና ኢንሹራንስ፣ ኤምኤስሲ በኢንተርናሽናል ትሬድ እና ኢኮኖሚክስ ዘርፎች በእውቀት ለመቅረጽ የበቁ ፕሮፌሰሮቻችን አረንጓዴ መብራታቸውን አብርተዋል። በነገራችን ላይ በኬንያ ሀገር ከሚገኙ ስመጥር ዩኒቨርሲቲዎች በሚመጡ ፕሮፌሰሮች የትኩረት መስክ ትምህርቶቹ መሰጠታቸው ልዩ ያደርገናል። በምርጥ የትምህርት ስርዓት የተገነባው ናሽናል አቪዬሽን ኮሌጅ በመጀመሪያ ዲግሪ በአቪዬሽን ማኔጅመንት፣ በሆቴል ማኔጅመንት፣ በአካውንቲንግ እና ፋይናንስ፣ በማርኬቲንግ ማኔጅመንት አስተማማኝ ትምህርት ይገቢውና ራስዎንና ሀገሮን ይለውጡ። አድራሻ 22 አደባባይ ወደ ሾላ በሚወስደው መንገድ ላይ ናሽናል አቪዬሽን ኮሌጅ የናሽናል ኤርዌይስ እህት ኩባንያ ህልሞን እውን ያደርጋል።
1.5 25.
The total?
Hello. Total
total?
1 point. Yes.
1.25. 25.
25. Yes.
Like that.
Yes.
Okay. What is the first case total? Like if you did the
case,
first
13
one.
points.
13.
13 points. First case 0.45.
And then the second case.
0.075.
Okay. The third case.
0.075 also.
0.075. The fourth case.
Fourth case 0.625.
0.6.
25.
The last case.
0.025.
0.025. So that it gives us this total.
Yes.
So what is the square root of 1.25?
1.1180.
1.1180. So that's the risk for project A. Project B. I just wanted to copy this so that for the sake of space, I can add the variables here. But you understand how we found this? So I'm actually trying to utilize the little space I have so that we have everything on the same board. So RA minus RB, okay, you square, sorry, not RB, RA, the bar, PI. So the figures we've been given are 4.8, 0.2, 1.083, 0.363, 2.601, 2.5.0, so that we get 13.887. So we've just brought this one down here. So you can do it at the same time so that you don't have to go through the several steps. If you understand what you're doing, I've just copied whatever was here and brought it here so that I eliminated the same thing that was here. And for the sake of space, because we need now to determine the covariances for us to be able to determine the risk of the portfolio. Okay, so here we'll need to also erase this, okay, so that we bring the other one here. So it's not only that you have to show everything. If there are things that you know and you can work out from the background, well and good. So 0.5, 0.075, 0.075, 0.625, 0.025, 2, so 0.45 plus 0.075 plus 0.075 plus 0.625 plus 0.625. Hey, Moges. Hello.
Yes, doctor.
If you add your variance for B, is it giving you 1.25 really? Can you confirm that?
I think so.
Because once you make a mistake here, do you have a calculator? Or you're using your head?
Can I repeat again? Can I repeat again?
Are you using a calculator or you're using your head?
Wait. Head through.
Your head. Let me confirm. Oh yeah, you're right. So 1.21, the square root of 1.25, sorry, is 1.1. Right. So this right and this right. Any question up to that point? We needed to erase this. We already have it there. So I want us to go into determination of the covariances. And what was our formula for determination of covariances? Because for us to determine the risk of the portfolio, we need to get the covariance between the two projects, A and B. Okay? So the covariance is determined by RA minus RB times PI. if you recall what we did yesterday, you know, covariance is given as that. So we get the difference between A's and the difference between B's, and then you get our PI. So it's actually the whole thing. Huh? So I was trying to employ the shortcut anyway, but it's okay. Let's go the long way. It is, let me erase this so that I don't confuse you. It is RA minus RA bar times RB minus RB bar. That's why whatever we had done earlier would have helped us find these figures easily, times PI. So can you work out this? So once you work out this, it will be able to give us, the total will give us now the covariance between A and B. Our RA, are we together? Our RA and RB, you already have that figure. What was RA minus RB? So RA minus RA, A bar. Kirima?
Yes, 4.9.
Okay, negative, isn't it? Remember,
Negative 4
signs are very important. So can you multiply with now the one for RB and minus RB bar? And then multiply with the probability.
Mm-hmm.
Zero point 0.43 to 1.
0.43 0.4
3 2.
0.432. What are you saying?
Negative
Negative
1.47.
Which is which?
For the first case.
Negative 1.47.
7.
Okay.
The second case, negative 1.9 time yes. Okay.
What do you get?
Time. Okay. Yeah. Negative 0.285.
Negative
0.285.
The next one, the third one.
The third one. Negative 0.165.
Negative 0.15.
65.
65. Okay, the fourth one.
Negative 1.275.
1.275.
negative 1. Yes.
Okay, the last one.
The last one.
Hey, they're all giving negatives because I don't know why. I thought the last figures were positive,
Which one?
like 26 minus 18, and then 10 minus. Okay, I see.
The other
All right,
side is
go
negative.
ahead. Huh?
Okay. 7.1
10.5 is
times
always above
negative
the
0.5.
others.
1.1 times 0.5 times 0.1. Negative 0.355. All are negatives.
So total. Okay, total.
Negative 3.3.
Negative 3.3.
55. Negative 3.55.
Negative 3.355.
Yes.
Like this.
Right. And what
That way. Another 5. Like this.
Which one? Yes, 3.55.
Oh, 3.55.
Yes. Yeah. Point.
5.
Yeah.
How many 5s after point?
Two fives. 2 5.
So it's 3.55.
Yeah, 3.55. Negative 3.55.
Okay, so that is the covariance. So how do you determine the correlation coefficient? The correlation coefficient, which is the pi, is equals to covariance AB over of standard deviation of A and standard deviation of B. So what is the covariance is negative 3.55. Right? The standard deviation of A is 3.726. 265 times 1.118. So when you work out this, what do you get? When you work out this, the lower one first, and then you apply the division.
Yeah. 1.065. Negative 1.05.
1 point.
Negative
Negative
1.065.
0.85.
negative 0.85.
521.
2. All right.
21.
0.85. All right, 21.
Ah,
So what can you say about this project?
it is good project because of negative relationship.
They have a negative correlation.
Yes,
and,
recommendable.
And the strength of the correlation is almost 0.1. Yes.
Yeah.
Because 0.8 is closer to 0.1. All right.
Yeah.
Because it's above 0.5. So if it's above negative 0.5, then it means it's strong. The correlation is strong. The correlation coefficient is strong, and means that these projects can be easily combined to diversify the risk. Are we together? The risk can easily be diversified by combining these projects in this combination of 50-50. The combination of 50-50 will work very well for the investor because of negative 0.8. All right. The highest is 0.1, negative 0.1. Sorry, not negative 0.1. The highest is negative 1. But here we're getting negative 0.8, which is much closer to 0.1 than 0.5. All right. So that's where we are. So with this, you can easily conclude that the two projects can be easily combined in the ratios that is planned for, and in a way they will diversify the risk, which means the investor will do well with the two projects combined in the proportion in which they are being combined. Now, the other last thing is how to determine the risk of the portfolio. What's the formula for a risk of a portfolio? Now you'll allow me to erase some of this area so that we can, because now we don't need these tables. We only need to work with these figures. We know the covariance. The covariance is already here. We know the weights. We know the weights. We know the risks of each portfolio, of each investment, which are given here. So we can erase this part so that we work with that. Unless somebody has a question before I do away with this. Any question? Kadir, are you with us? Girma, you okay?
Yeah. Yes, I'm okay.
Amabet, you okay? We've lost you.
Mabet.
I'm taking time. I'm taking time to give you this so that you understand how this comes about. because this is a very tricky area and most students don't get it right because you fail in probably addition or multiplication of, or subtraction of this because it involves negatives, positives, and again, a lot of multiplications and addition. So once you do a mistake somewhere, you will find that your end results will be wrong, and therefore you'll be bound to make wrong decisions.
Okay.
Right? Because now, like to arrive at negative 0.8, you must have done well with the calculations up there. Otherwise, you will get a wrong correlation coefficient, and therefore you will make a wrong decision based on the one you would have found, which could be misleading. Okay, so let's do the determination of the risk of the portfolio. And I hope you all remember the formula. What was the formula? Who can give me the formula? We had it yesterday. Huh? Is equals to? You've forgotten. WA squared. Yes. A squared plus WB squared. This one, you need to have it at your fingertips. Plus 2 weight of A, weight of B, times covariance of AB. I gave you this formula yesterday, and you can confirm it from here. Okay, this is the formula. 2 times weight of A, weight of B, not square. All right. So can you substitute? And actually, for us to get the risk, it's the square root of all that. So this is equals to weight of A is 0.5. Are we together?
Yes.
Times standard deviation of A is what? 3 point. 7, 2, 6, 5 squared. Okay. Plus weight of B squared 0.5 squared. 50% is the same as 0.5. Okay. .5 times standard deviation of B is 1.118 squared. Okay. So times 2 times 0.5 times 0.5 times our covariance for A and B. Covariance for A and B is negative 3.55. So what does this one give you? If you work out all this, probably you could go in stages. Work out this first, and then this one, and then this one. Work out this and this, you add, then you multiply by all this. Give me the answer.
I think 0.7341181.
The last one.
Hello. The last one.
The first
0.7. 0.
Okay, let's be orderly. Starting with the first case. What was your answer, or how did you go about it? You worked
Okay,
out
0.
everything at the same time? The first case.
The first case 0.5 square.
Yes. Times this. What do you get?
Times this, you get 3.4717. Get
Remember, you had this with
3.47.
us earlier on. You guys.
Yes, sir. 0.5 square.
When you square 0.5 square, you get 0.25, right?
0.25, yes.
Multiply by 13.887.
86807, okay. It will be 3.4717.
Yes. Not
At the
zero.
same time.
So it will be
Plus
3.47
17
plus, work out this as well.
0.25
0.25 times
1.2499.
1.25.
5, okay.
This is what you gave me here.
0.31248.
3125.
Yes. Sum of these two.
Then
Add.
multiply this all the way. What do you get? 2 times 0.5 times 0.5 times negative 2 times 0.5 times 0.5 times negative 3.55, right?
Times.
This is negative 1.
Okay.
1.775. So when you add the two and multiply by that, 3.47175 plus 0.3125, it will give you 3.78425 times negative 1.775, which would give us negative 6.7170. Am I correct? Am I correct?
Mhm.
So our standard deviation of the NNE is equals to square root of that negative 6.7170, which would give us what is the square root of that? Seven one seven. There's something wrong somewhere. Yeah. What is the problem? Hello?
LS.
Yeah.
Hello, now it's correct.
Yes.
It's correct. I think something is wrong.
Yeah. Something wrong
Something is
somewhere.
wrong. Yeah.
Yeah, but
why we make multiplication here?
Huh?
Multiply.
Where?
Multiply this one here.
Which one?
3.471175 below it. Yes, plus.
This one.
Then, yeah, we have add. It's correct, right? Plus this one, but we must add. Instead of multiplication, we must add the results.
We add.
Yes.
So
you see
when
the
you
figure
add
in
what?
the square root. In the square root, you see
Yeah.
the square root
It should be
plus
most.
2. It is. Both things are right. However, in the square root, the formula says that weight of A square plus standard deviation of A plus weight of B plus plus 2 times weight of A. We are instead of this one, we are multiplied here.
Weight
instead
of A,
plus.
weight of B.
Covariance.
It's
This one.
addition.
Yeah, addition here.
Really?
I think the formula says that weight of A square standard deviation of A square plus weight of B square plus standard deviation plus says this 2
times weight of A
plus
times weight
here
of
is
B
plus. Yeah.
times covariance of AB.
Yes.
Times covariance of AB.
Yes. And instead of multiplication, we have to add this. This is the first numbers.
So what is your answer according to your calculation?
Just I'm searching what's the problem now.
Okay.
So if you're waiting.
Times 2 times. Is it plus 2 or times?
Plus. Here is plus. According to the first questions, it must be plus.
Plus 2, plus 2, plus 2.
Yes.
Okay.
Have you got one?
Oh, yeah. This one is supposed to be plus.
Yes, it's positive plus, yes.
Thank you for that correction. Because my figure was not coming up. Good. Yeah, so when you work out that, actually that one will come positive. Because I was wondering, why is it coming negative? So when you work out that, you'll get that, and then now plus, so it will give us 2 times 0.5 times 0.5 times 0.5, yes, times negative 3.55, which is negative 1.775. And this is plus.
This is
as
plus,
well.
yes. That's right.
Yeah. That is plus as well. Sorry for that. So when you work out that, so you should get 3.44715, all right, plus 0.3125 plus 1.775. All right. You're right. So this would give us 2.00925. So the square root of that will not give us that, but should give us the square root of 2.00925 should give us 2.00925 should give us 1.4175. So that is the portfolio risk. It should give us 1.4175. Girma, am I correct?
Yes.
Yes, just confirm that. Confirm that.
Yes. Okay,
But it should give you that.
Okay.
Give you that. This makes sense.
Okay.
Makes sense.
Okay.
It makes sense because the risk of A was 3 point something, for B was 1 point something. So it should be lying in between there. So which is 1.4. Yeah. Good. Any question?
We don't have.
Yes, you now need to do a lot of practice in this area. As you can see, it's a very demanding area. It's just one of the steps that we do in terms of evaluating projects, in terms of portfolio formation, so that you can decide which portfolio is good and which one is bad. Now, when it comes to risk-return relationship, you look at the risk of the portfolio. The risk of the portfolio is 1.4175, and then the return of the portfolio is 14.75. So you'll be comparing this return against other portfolios, other formations that can come about. All right. So you are comparing that this of 0.5 to 0.5 with others. All right. The others that may come about, or a different combination other than 0.5, right? So that you see where you can maximize returns, so that you can decide, even if you only have the two, you decide where to put a lot of effort and where to put a lesser effort. So this is the beauty about portfolio, and you need to read a lot about it. We shall be continuing a lot with this, where we now will have to bring in the issue of market and the operations, because we have risk-free markets, risk-free securities in the market, and risky markets, risky securities in the market, so that we see how, if we combine the same in the market, what would be the cost? Because here we are looking at assuming all projects have a risk element. But there are cases when we can have some projects which are risk-free, like treasury bonds, treasury bills, the ones that are issued by the government are preferred, are looked upon like they are risk-free. So let's look at that, and then we'll compare notes the next time we meet. Otherwise, I'll be sharing this in the course of the week so that we are up to date with our notations. All right?
All right.
Any question, any comment? We yesterday I saw a new member joining us, and we had allocated areas for discussion. So you need to send me
again.
Huh?
You send me again.
Send me the. I'm saying.
Yes.
I had sent you the updated list of cost allocation and the allocations of the members or areas. I also sent you the areas we discussed last time. I hope you found that and you shared.
Mm-hmm.
Did you?
No, I can share it before this one.
Yes. I mean, before we met yesterday.
Yes, of course, you're sharing for them.
You saw whatever I had shared.
Yes.
The notes and the new cost outline.
Yes, I'll share them. But it is necessary to add updates because of new coming.
Yes. Yeah. You got that one?
I don't have.
Okay.
He's joining us this week.
Can you recheck your mail and then just acknowledge receipt so that I can follow where we last communicated?
Okay.
And then now you send me the new member who is coming in, because I've been trying to get hold of him so that I can hear him as well. But I think because of network, we were not able to communicate. Otherwise, let's work with that. Just acknowledge whatever I received you received from me last, so that I know where we are and I can update you accordingly. And if there are any new members, just share the names so that I also allocate them. Wow. All right. Anyway, I'll stop the class for today. And I look forward to meet you again next week so that we continue from where we have left. And as I had said, I hope I'll be getting the communication from the president.
ልዩነት መፍጠር ዓላማችን ነው። ዓለም አቀፍ ተወዳዳሪ መሆን አለባችሁ። የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ጥራትና ደረጃውን የጠበቀ ስልጠና በመስጠት ብቁ ዜጋ እያፈራን ነው። በፍላይት ኦፕሬሽን፣ በበረራ መስተንግዶ፣ በቲኬቲንግና ሪዘርቬሽን፣ በሆቴልና ቱሪዝም ሙያዎች አሰልጥነን ተወዳዳሪ እናደርጎታለን። ኮሌጃችን ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ICM ጋር በመተባበር ዓለም አቀፍ ዕውቅና ያለው ስልጠና እየሰጠ ይገኛል። በፍላይት ኦፕሬሽን በበረራ መስተንግዶ የምንሰጣቸው ስልጠና ከኢትዮጵያ ሲቪል አቪዬሽን ባለስልጣን ሙሉ ዕውቅና አለው። አድራሻ ከጎላጉል ታወር 22 አደባባይ ወደ ሾላ በሚወስደው መንገድ ላይ የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ህልሞን እውን ያደርጋል።